Thank you, everyone, for coming. And thank you to Franco for arranging this and for the invitation. I really appreciate it, especially because today the Ithaca City School District, where I live, is closed due to wind chill. So I really appreciate the sound of the birds coming through the open patio door. So I knew that I was going to be speaking at the end of the day, so I wanted to have a kind of bringing everything together kind of talk. And one place that I like to start is this quotation from George Box. Essentially, all models are wrong, but some are useful. I like this quotation so much that I had it printed in 3-inch high vinyl letters and stuck to the wall above my desk. So that is my office. Matt pointed out that there are no books on the shelves. I do have books, they're just not that part of the shelf. But my role in this place is not as a literary person. I have some smidgen of classical training, but I'm a quantitative person. I work in statistical data analysis. Numbers are my bread and butter, literally. I make the money that I buy bread and butter with numbers, and I think it's important to say that from that perspective, I have the same kind of misgivings about numbers that a lot of people who I think are very skeptical about the whole quantitative text analysis project have. That was an unnecessarily complicated sentence. Which is that numbers and quantification can give people this sense of authority that they don't necessarily have. And I would almost go so far as to say that numbers in the 21st century have taken the place of the gentleman of means in 19th century England. This is someone who is considered to be just essentially incapable of fraud or deceit. And from my perspective, as someone who writes algorithms for a living and designs these things, is that the fact that a computer program has run on a set of data and come to a successful conclusion, like without dividing by 0 or something, and has produced numbers that it has written into a file, is not evidence. And so those are the two words that I want to sort of play with in this discussion, the idea of numbers and the idea of evidence. And it's important to start. I also want to assert that what links numbers and evidence is models, and that having models that operate on representations that may be trained or assembled through algorithms and phrased in the context of interpretation. These are six nouns, and I think that whole sequence, and I'll go over this in more detail, is what brings us from numbers to evidence. So I wanted to start by talking a little bit about what I mean by evidence, or what we think of as evidence. There's this sort of scientific sense of evidence, of something that exists in a statistical framework. There's the rhetorical idea of evidence, that it's something that is supposed to persuade someone of something. It has rhetorical weight. There's even the forensic idea of evidence. It's sort of the things that you can pick up, the blood splatter from the murder. And we'll see if I can pull that one in by the end. Just wait. So being in Silicon Valley, I've been told that the thing that you do here is called dog fooding, eating your own dog food. So, I went to JSTOR, and I asked it for the humanities. Sorry, I'm not supposed to point with my fingers. I asked for the humanities discipline, and I asked for the word numbers, and I got 203,000 results. And I asked for the word evidence, and I got 467,000 results. I invite you to speculate on whether this is a number or this is evidence. But I think it's at least some indication that humanists are more comfortable with the idea of evidence than they are with the idea of numbers. So what do we want from a model? Well, I've started working in the last couple of years in this very interesting environment, which is, it's a department we call information science. It's kind of it takes people from computer science as well as communications and science and technology studies. And so I was kind of workshopping this talk with my colleague Phoebe Sengers and her graduate student Samir from a science and technology studies background. And the concept that they brought into the discussion was this idea from this field that technology gives us an alien presence. It's like this robot which is observing us, or observing human activity. And what's interesting about this is that the robot, the alien presence, has a perspective that is different from our understanding of our activity, or our understanding of the world. This is literally a robot flying in space, which has the same perspective in some sense that I can get by looking at the hills outside. And if you can't see it, the left is the beginning of January 2014. The right is January 2015. California suddenly became green. So this is a to pull in Franco's terminology, that this is a macro perspective on my micro perspective from outside the window. And it's mediated through technology. And what technology gives us is the ability to see the large perspective. Okay. And when we think about the robot perspective versus the human perspective, it's always contextualized, again, pulling from science and technology studies, in a community of interest. There are other people in the community who are watching both my understanding of the text and the robot understanding of the text. And a question becomes interesting when it is interesting to that community, when it makes sense to that group. Okay. And again, I want to hypothesize that it's models that help us to understand what is that robot perspective, and algorithms. So I think it's time to define more what I mean by models. I mean, Phoebe's response was, well, you could spend the whole talk talking about models, never even get to evidence or numbers. Usually what I mean is a fairly specific thing. It's an equation. I'm talking about a statistical model that sets up a mathematical relationship between known and unknown variables. But I think it's really valuable to think of models not just in this abstract mathematical sense, but in a very literal sense of scale models. It's from Zoolander. I didn't put the citation there. And I think that this is an interesting and very valuable perspective on what is it we're doing with statistical models of literature, and what are our expectations, and what do we hope to get at it. The model, again, taking this very literal sense of a scale model, is taking a vast corpus, more than you could possibly read, and packing it down to something that you can kind of look into and get the overall sense of. And I won't say whether or not this is what I think when people complain about topic models. Okay, so the other thing that this really pulls out is what is the representation that a model is working within? So this is a representation in terms of little bits of foam core and plastic. And I think it's been really valuable in this talk to hear people thinking carefully about the choices that we make in representations. And as many people in this audience know, I love analogies. And I have this other analogy in terms of representations that I want to spend a little bit of time with, because I think it's really informative, again, for how we use models to go from numbers to evidence. Do people know what this is? It's Minecraft. So Minecraft is this amazing thing. I've learned about it recently because I have young children, but it's the intersection of that Venn diagram between things that run arbitrary Java code and things that 9-year-olds will spend hours looking at without being asked. So I think that this is fascinating. I'm really interested in Minecraft, but you can see that the representation of Minecraft is as this gigantic 3D grid of cubes. That's it, essentially. There's also sheep that are slightly. There's different types of cubes. There's different types of these blocks. They have different characteristics, but they're all blocks. And given that representation, people have gone through and made incredible models of things in the real world. So, for example, this is, I know we have a few Cornellians here. So this is the Johnson Museum. It's IMPE at Cornell. This is a model by E. Bryan or Ebrian. These people are artists, and I want to recognize their work. And I would argue that this representation of the Johnson Museum as Minecraft blocks, it gives you a lot of information about this building. The general shape is quite correct. You know that it's gray and can probably speculate that it's concrete, bare concrete. And you can even say that perhaps this building was deliberately designed in a way that happens to be very amenable to a representation as Minecraft blocks, as opposed to, say, this guy. Again, apparently it took this artist, and I really want to say artist, 4 months to build this model. This is, okay, here's a good question. Can people recognize this building? This is La Sagrada Familia, Antoni Gaudí in Barcelona. And again, I think you can get a sense of this building. It's a cathedral. It's big. It's got pointy towers. It's sort of yellowish. It has a texture to it. But I think it also, there are aspects of this building that this representation is fundamentally not capable of capturing. And I would also go further than that and say that this building is fundamentally less Minecraftable than the Johnson Museum. Because if you go to, so you can get the overall sense of it, but you're missing the fact that there are no straight lines. It is all curves. There are sculptures. You also miss, and again at a different level, not just the things that you know where they would be if they were there, but you miss, I would say, the emotional effect of the building. This building is designed to create a feeling in human beings, and I do not think that it is fully representable in this framework. Oops. Giving away the secret here. Okay. This is another model. This is another representation. This is US states. I'm representing US states as two numbers, which I'm mapping to the X and Y axis. The X-axis happens to be population density, or log population density. Alaska is very low density. District of Columbia is very high density. The Y-axis happens to be reported gun ownership. This is an example I used in the final for my D3 plus machine learning class last year. And you can sort of tell that there's a relationship between these two variables. As population density goes up, gun ownership, reported gun ownership, you can speculate about District of Columbia, reported gun ownership goes down. And we can make that model concrete by drawing a line through it. That line is an element of this model that was constructed by an algorithm. So there's a formula you can run that finds the best line for this linear model. And given that line, we can look at specific cases like Alabama. Again, I'm biased towards the things that are sort of not overplotted. That was a good point that came up. So most of the information is down here, but I'm going to talk about Alabama because you can see that. Alabama is a moderately dense state, but it has higher than expected gun ownership. And I can say expected because I have that model. I have that line, and I can measure the distance that Alabama is above the line. Another thing I can do now that I have a model is I can phrase this model by saying that as population density goes up, reported gun ownership goes down. And I can imagine another world where there is no relationship between those two variables. And I can even simulate that world by keeping the x dimensions the same and randomly shuffling the y dimensions. And I can record what the linear model would be if that was the actual world. And let's do that a few more times. This is designed to keep you awake at about the 15-minute mark. And I can build up a sense of what this, to throw out a term, null distribution would look like. They all go through the middle because this is the mean of both empirical distributions. And I can sort of count the number of lines that my actual line is steeper than, and that's a p-value. But I'm not going to talk about it that way. I like this intuitive view of the model. So again, I've got my model. I can look at it in terms of the things that it gets right. I can look at it in terms of the things that it gets wrong within the context of the model. I can then speculate. Well, I can do tests on it because I have a model. I can speculate about what are the things that are going on here that are fundamentally not representable here. Because remember, my representation is two numbers. So what about culture, religion, poverty, identity, any number of other things? These are just not present in the model. I've chosen through my representation not to pay attention to those things. Okay. Nobody brought me here to talk about Minecraft or linear regression. I'm here to talk about topic models, of course. And I don't want to embarrass Dr. Goldstone with his random tweet, which I think I've hopefully been setting this up. This, I think, is incredibly useful taxonomy for how we use models to turn numbers into evidence. And I'm actually going to propose that we refer to these as the Goldstone Stages. Andrew has settled into his chair. He'll be on the floor before. So let me just read them. My cycle of topic model interpretation. Wowza is stage 1. Well, but, stage 2. Despair, stage 3, and some kind of stage 4, which is kind of okay. I mean, Doane, you're done. This is a web page, so it will go on my website. Okay, so let's think about these stages in the context of topic modeling. So I'm sorry, these are a little small. So this is a topic from a model that Matt trained on 3,400 English language novels from the 19th century primarily. There's a total of 500 topics. This is the one arbitrarily assigned to number 14. Matt has described it as education. So the thing in the brackets is human. Everything else is in descending order the probability of each word, I think this is pretty good. These are words that sort of have a coherent structure. We're kind of stuck with the nomenclature of topics. We can sometimes get away with calling them themes or discourses, if Ted is in the room. I think that these are really more like word blocks. And that's why I like thinking about Minecraft, that this is the representation of a probability distribution over words, and you can construct 19th century literature out of it. But it's constructed at the level of these square blocks, cubical blocks. And that restricts us, but it also gives us a certain amount of modeling freedom. Over here, this is a plot of this topic over novel time. So we've taken all of the novels that have a non-negligible proportion of this topic. The long ones we've squished down, and the short ones we've stretched out so they're all sort of proportional to each other, and we've calculated the mean concentration over these novels of this topic at the beginning, the middle, and the end. This is over, I think, 20 segments of novels. The gray area shows you one standard deviation on either side, so there's a lot of variation. You should not be confident that this is exactly where it is, but you can be sort of confident that the beginning of novels have more of this education language, word block, than the ends. Here's another one. Thoughts and the mind. Thoughts, mind, thought, reflections, reflection, reverie, hours, train, meditations. I've shown you, I like to show a lot of words because I think it's first of all a tribute to the work that Matt did in constructing this model. These are very, very good topics. I think they're very tight. This one is one that's kind of in the middle. It doesn't appear to occur with greater concentration at the beginning or ends. I've made these on the same scale, so you can directly compare these. Here's one. You can probably guess why I chose this one. Most probable word is evidence. And prisoner, witness, trial, jury, case, counsel, witness, verdict, defense, testimony. What this seems to be saying is that the concentration of words about trials increases over the course of novels. So at the beginning of novels, you're being educated, on average, with a lot of variability. Towards the end of novels, you're on trial. And this is we try to make sure that our students are on trial after they graduate from Cornell rather than before.
Is this only for novels that include this topic?
Only for novels that include this topic. So that's a choice that I made, which may or may not affect the results. You could even speculate that there is sort of a bump in trials in the middle of novels, a lull, and then another bump. And there is a slight dip. The appeal, yeah. There's a slight dip in the variability, but again, these are not numbers that you should have a lot of confidence in. Okay. So what's the equivalent of a model test? So let's take the words that are assigned to a given topic. Here's one that we were interested in, about convents and abbeys. Take all of the tokens, not the types, the running tokens that occur in that topic, and divide them in some arbitrary way. For example, I've taken the tokens from this topic that were present in female authors and put them in a pile on the left, and the tokens present in male authors on the right. And I can do the same sort of thing where I can measure the average concentration of a given word within the topic, so within that context, in one partition or the other. So maybe we think that the word none occurs more in words written by female authors, monk more by male authors. And then we can do that same sort of randomization test. where with some probability we flip the gender of a given token and re-estimate our statistics. So sometimes a word stays on the same side, sometimes it doesn't. Sometimes it flips. And we can use that to build up an empirical sense of where that number would be if there were actually no association between specific use of words within a topic and some variable of interest, in this case, gender. I apologize for the size of the text. I will read some examples. This is the actual data. So you can see the word abyss. Again, this is a log ratio. It occurs way out here on the female direction. All of our replications with randomized data kind of sat somewhere in this region. So a word like vows, right here, is actually squarely in the middle. So it seems like there's no reason to think that male or female authors use the word vows within this topical context more or less. Nunnery, that was an interesting case, is way out of the expected range on the left side or on the right side. So this is a very male-associated word. So again, because I have this robot presence, this alien presence that has a particular model, an algorithm, I can use that model in order to gain an understanding what the expectation of that is, and look specifically at the residuals of the model to understand where is it within its own context going wrong. Let me read that for a moment. So this is Joyce after he had written something like 2 sentences in 2 weeks. He says, I have the words, but I don't know what order they go in. So our representation that we've chosen that locks us into certain interpretive possibilities is that word order doesn't matter. That we treat each segment of text within that segment as an unordered bag of words. And I think it's very clear that we have locked off certain possibilities of analysis. There's also you can think about the effective power of novels. You know, we had that example earlier today of the flight attendant who remembered Atticus Finch. And, you know, I and my sister, you know, we mediate our relationship with our father in some way through that character. That's a very powerful effect. And I would suggest that that's similar to the difference between walking into Sagrada Familia and seeing the Minecraft model. I've actually never been inside Sagrada Familia. I've been outside, saw the lines, and turned right around. I will go there someday. But there's something fundamental that's missing in the model. There are many, many things that are fundamentally true about novels that we have no possibility. We have locked ourselves away from the possibility of ever representing. So is there a stage 4? So I was describing Goldstone Stage 3, despair, just now. But I think there is a stage 4. And what gives me hope is especially some work that Lisa Rohde did. This is from the Journal of Digital Humanities a couple of years ago. She did a topic model on 4,500 ekphrastic poems. So these are poems that describe art. And she came up with these topics, for example, this one about night, light, moon. So it's descriptions of the night sky, particularly of sort of vastness and infinity and darkness and yeah. And by itself, these words, they're coherent. We're not surprised to see any of these words together. But when Lisa looked at the poems that scored high in this topic, again, looking at outliers, so maybe we can speculate about the method, but when she looked at the poems that contained this topic, they were all metaphors for death. And the second topic here, the death, life, heart, dead, long, world, blood, earth, again, this is sort of a confusing topic. We're not quite sure what it is from looking at these words. But when she looked at the examples, they all had the poetic form of the elegy. And I would suggest that no one who should, well, I'm not going to speculate about who should be fired or not. No one who should be taken seriously would define a poetic form in terms of a sequence of words that are probable in that topic. Just as no one would say that the metaphor is really defined by the surface form, the concrete language. And yet, the literary event of the metaphor, even though we have completely lost the actual meaning, has still left traces. It's left forensic evidence of itself in the language. So we don't know what the metaphor is from this model, but we know perhaps that there is a metaphor, or that there is something going on. There's a poetic form going on. And it leads to speculation about, even when we cannot possibly represent what we think is there with the representation in the model that we've chosen, is there some level of interpretation? Remember, this only came through when Lisa went through and looked at the actual poems. Again, echoing what we heard before, that you have to go from the large to the small in order to make any of it make sense. That combination of exploration guided by the model, informed by the algorithm, is what allowed us to make progress, and allowed us to create evidence and persuasive arguments that were based on numbers. So I think that might be a good place to stop.